I just downloaded a company's internal database credentials and AWS access keys. No username, no password, no hacking tools. Just one command. And the scary part, this exact misconfiguration has caused some of the biggest data breaches in cloud history. Today, I'm going to show you how it works, how to detect it, and how to stop it. What's up, everyone? I'm Amin, also known as Ghoul. I'm a cybersecurity graduate, and I've spent the past few months building a hybrid on-premises and cloud SOC lab that I use to practice on real attack and defense scenarios. Today, we're covering the AWS phase of that lab. I'm going to walk you through 2 real attacks against a vulnerable AWS environment, the same techniques attackers use in the wild. Then show you what the evidence looks like so you can detect it. If you have never touched AWS before, don't worry. I'm going to explain everything from scratch. Let's get into it. Before we attack anything, let's make sure we understand what we are dealing with. AWS, Amazon Web Services, is the world's largest cloud platform. When you use Netflix, Airbnb, LinkedIn, or pretty much any modern app, there's a good chance it's running on AWS behind the scenes. For our purposes today, 3 services matter. S3, Simple Storage Service. Think of it like a giant hard drive in the cloud. Companies store files, backups, application data, images, everything. The problem, if you misconfigure it, anyone on the internet can read those files. EC2, Elastic Compute Cloud. These are virtual machines running in AWS. Every EC2 instance has something called metadata service, a special endpoint that gives the machine information about itself, including its security credentials. IAM, Identity and Access Management. This is the permission system for everything in AWS. Every user, every application, every service has an IAM identity that controls what it's allowed to do. Get IAM wrong, and an attacker with the lowest privilege account can silently escalate to full administrator. Here is the environment I built. You can find the full repo on my GitHub. Link is in the description. On the AWS side, I have 3 things running. CloudTrail. This logs every single API call made in the AWS account. Every time someone creates a user, downloads a file, changes permission, CloudTrail writes it to a log file. This is your forensics evidence. GuardDuty, AWS Managed Threat Detection Service. It sits on top of CloudTrail and uses machine learning and threat intelligence to automatically flag suspicious activity. Think of it as an automated SOC analyst watching your logs 24/7. I turned all of these on before I deploy any of the vulnerable resources. That's intentional. In a real environment, detection comes first. The interesting thing is that GuardDuty immediately started generating findings just from the misconfigurations I deployed. Before I even run a single attack, we'll see those findings in a minute. Now let's attack. Attack number 1, S3 public data exploration. And here's the setup. I created an S3 bucket, then uploaded a file called credentials.txt, containing fake database password and AWS access key. Here's what the misconfiguration looks like in the console. Block public access. All 4 settings disabled. Bucket policy, get object allowed, and for principal, star meaning everyone. ACL, everyone granted list and read. 3 layers of misconfiguration stacked on top of each other. This is realistic. Real breaches often involve multiple settings that each needed to be wrong for the attack to work. Now you might ask, why would a bucket ever be public? Sometimes it's intentional. A company hosts a public website from S3, but often it's accidental. A developer enables public access to test something quickly and forgets to turn it off. But they don't realize that disabling one setting isn't enough. On modern AWS accounts, you need to disable block public access and add a bucket policy. Now I'm on my Kali machine. I have 0 AWS credentials. I'm not logged into anything. I'm just a person on the internet who found a bucket name, maybe through a GitHub repo, maybe through an error message in a web app, maybe through a Google Doc. Watch how simple this is. The no sign request flag tells the AWS CLI to make an unauthenticated request, no credential, no account, nothing, and the bucket just responds. It shows me the file, credentials.txt. Let's grab it. Database host, admin username, password, AWS access key, all of it under 20 seconds. No brute force, no exploit, no malware, just misconfiguration and one command. Now let's look at what the defender sees. Here's GuardDuty, and there are actually 3 layers of detection here, which tells a really interesting story about how modern cloud security works. Layer 1, before I even run the attack. Bucket anonymous access granted, high severity. This fired the moment I applied the public bucket policy. GuardDuty doesn't wait for an attacker. It flags the misconfiguration directly. Bucket block public access disabled. Fired when I turned off block public access. A well-configured SOC would have caught this before any attacker even found the bucket. That's the power of GuardDuty. It's not just detecting attacks. It's detecting the condition that makes an attack possible. But here's where it gets interesting. Layer 2. After I run the attack. Malicious IP caller.custom. The API list object was invoked from a remote host potentially running Kali Linux. GuardDuty fingerprinted my attacker machine as Kali Linux from a single S3 API call. It didn't just detect the anonymous access, it identified the operating system of the machine making the request. CloudTrail captured the exact API call. Get bucket ACL and list object from my IP, my Kali machine against Google public data, timestamps, source IP, bucket name, exact operation, all logged. 3 layers of detection for a 20-second attack. GuardDuty caught the setup. GuardDuty caught the attack and fingerprinted the attacker. CloudTrail has the forensics receipt. This is what good cloud detection looks like. So that's attack 1. No credentials needed, 20 seconds, game over. Now attack 2 is completely different beast. It starts with a compromised developer account with low privilege and ends with full administrator access over AWS account. It's one of the most dangerous attack patterns in cloud security, but it will be in part 2. If you don't want to miss it, subscribe. And this is Amin. See you in part 2.